Hello, everyone. Let's solve another Leetcode problem today. And this is one of the easy problems, but this is one of the problems with linked list. So doing this problem will help you do some exercises on solving problems with linked list. Okay, so let's go to the problem definition. As you can see, this is problem number 21 in Leetcode. And we have to merge two sorted lists. Okay, so you are given the head of two linked lists, list 1 and list 2. Okay, so we are given two heads, this and this. Okay, and we have to merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. That means we are not allowed to create a new list, create an entirely new list and just copy the values, like one copying from here and then copying from here, another one, then copying from here to copying from here. So this is not allowed. Like creating a entirely new list is not allowed. Rather, what I have to do is we have to use the existing node. So basically, our new list is going to be just using the same things. So basically it would be like 1, then this will be linked to this, right? That means this is going to be erased, right? This is going to be erased and reassigned to like here. Okay, next this is going to be erased and this link is going to be this link is going to be reassigned here. Okay, and then the next one is going to be erased and not erased, actually reassigned here. Okay, similarly this next is going to be reassigned to, say, it can actually stay in the same place, but just for the purpose we reassign to it. And finally this gets reassigned. So this is going to be my output. Okay, so how can we do this? So as you can see, can we say okay, so initially what you can do is we can have a dummy node, right? A dummy node. This is always a good technique to solve the linked list problems, to avoid the edge cases. We have a dummy node, and then we'll compare between this and this, right? Okay, so comparing between this and this, I will see that, okay, I can take any of the nodes. Let's say I take the node from L1. So whichever is the smaller, because as you can see, these values in the nodes are in increasing order. So we make this node as my next node. And then, so now L1 is going to be pointed to this, right? Okay, so next time I will compare between this and this, right? So initially I was comparing between this and this because they have, let's start again. So I have a dummy node. I created a dummy node and then I compare between the first two elements, right? And since both of them has the same value, I just take one of them and make it my next node. So next to the dummy node. And then I compare, so we are done with this, right? We are done with this. Next, I compare between this and this. And since this is smaller, so I make this link as my next, as I said, like by erasing, like reassigning this next to here. Okay, so next, that means we are also done here. So next comparison is going to be between these two, right? And we see that this is smaller, 2 is smaller. So what we do is we erase our pointer here, right? And reassign the next here, okay? So what we can do is we first create a dummy node, and then we can create another node and say current node equals to dummy. So initially, the current node is here. And then what we do is we check between, like, initially the current node is here. Okay, let's make it a little bit more clear. So initially this is my dummy and also this is my current. Okay, so what I do is I compare between 1 and 1. I compare between 1 and 1. So this is from list 1, this is from list 2. So I compare between them, and what I do is I make one of them the next of my current node, right? Okay, and then what I do is I make it my current node. So next time I find another node and I make it the next of my current node and change the current node to this node, right? So next one, once I actually make a comparison between 2 and 3, I make 2 as the next to my current node and change the current node to this, right? Next, I make a next 3 as the next of my current node and change the current node to 3, right? So next time I compare between 4 and 4, and whatever is the lowest is going to be my next, right? And then I will change the current node. So I will keep on doing this. Okay. And finally, you see that we'll keep on doing this until we reach a null somewhere. So say this one will come here, right? This next will be pointed here. And then comparing between second. So next, this thing is, if 2 of the values are actually the same, we can take from any of the lists, but we have to be consistent. So we are taking from the first list, okay? So we are here, and next time you see actually here we have a null, right? We have a null here. So what we do is, if we reach a null, we cannot actually compare between null and this. And so instead what we do is we take the rest of the list. So now the list looks like this: 1, 1, 2, 3, 4, right? And next what you do is one of the lists are like exhausted, done, right? So for the rest of the list, we just add it back here. So suppose this list might have more values, 6, 7. What you could do is, since we are exhausted, like this is done, once one of the lists is exhausted, we can just take the whole thing from here and add it here. That means I just add this whole thing, 4, 6, 7. Okay, I just add the whole thing at the end. Is it clear? Okay. Okay, and if both, in the example 2, we see that if both the nodes are like empty, then I just have to return an empty node. Even in that case, I first created dummy node, right? And then I can also say like current. So, okay. And then what you can do is we check that if any of the nodes are like null. if any of the nodes are null, what we do is I just take the other list and add it to the end. Okay, and so let's go to our code. I have already coded this, so I'll try to explain it. Okay, so you see, this is our, say, dummy node, or say current node, and okay, let's make it dummy. Okay, and then I assign the same node to, okay. Before doing that, let's see how the list node is created. So there is a class with list node already like created here in this program. If you are actually doing it from scratch, you have to create it. So this is a class defined for a node. This is a node class. It has a value and it has a next pointer. Okay, so any node has a value and the next pointer. That is what linked lists are like. So initially we create a dummy node. It actually helps us avoiding the edge cases. And then we assign the current node to the dummy node. That's fine. And we will now start comparing between list 1 and list 2, right? List 1 and list 2. How long will compare? Until both of the lists have some values, like one of the lists are not exhausted. Okay, so we'll check if none of the list nodes are empty. If until none of the list nodes are not empty, that means list 1 is not null and list 2 is also not null. And then I will check if list 1's value is less than equals to list 2's value. If that is the case, then I assign the current nodes next to list 1. That means here in this case, this one is going to be the next to my current node. And what I will do is I will move list 1's from list 1 to list 1's next. So next time from list 1, this value 2 is going to be compared, right? So list 1 now is pointing to 2. List 2 is now pointing to 1. Okay, so next time when I come back again, yes, both of them have values. Now I compare. Now, this time you see that list 1 will have a bigger value. So we'll go to else. What I'm going to do is, we had actually changed the, say, current node to current next. That means the current node was here, right? Outside. Next was assigned to this. This was made the new current. Okay, now we are comparing between 1 and 2. 1 is smaller. So what I do is, this is the current node, right? So I set the currents next to this node. Okay, so and then I make it current again. Okay, and I move the list 2 to 3. Next time list 1 is here, list 2 is here. I compare both of them. Okay, I compare both of them. And this time you see that list 1 is smaller, right? What is the current node? Here, right? Okay, current node is here. So we make the next to current node as 2. So we keep on doing this. As soon as one of the nodes become, like one of the lists is pointing to null, as soon as that's happening, so we'll check if list 1 let's make it easier. If list 1 is already pointing to null, then what we do is, for the currents next, we assign the whole of list 2. Otherwise, we assign whole of list 1 to the currents next. And finally, we return. So can you see that? So basically, this was our dummy node, right? So say dummy dot next. Okay. Okay. Okay, so let me show you one more time. I think I made it a little bit not confusing actually. Let me show it one more time what this code did. Let's erase everything and draw my own list. So say this is L1, this is L2. Okay, so L1 was like this, and basically there's a null here, right? L2 was like this. Okay, and let's assume there is another one in L2, and there's a null here, right? Okay, so we created a dummy node. We see it here. And we also assign the current node also to the dummy node. So this is my current node and dummy node. Okay, and then, so that's exactly what we did here. Okay, now we check if, okay, so list one is now pointing here, right? List one is pointing here. List two is pointing here. Okay, so then we see that, okay, none of list one and list two are null. So what I'm going to do is, I'm just going to compare them, and whichever is the smaller value, I will assign currents next to that and then move that list. So that means between this and this, list ones, now they're similar. So I will take from list one. So what I'm going to do is current. So this is the current node, right? So I make it next, assign the next here. I will make it current, and then I will move L1 to this. Do you get that? Okay. Next time, L1 is still not null. L2 is not null. L2 is here, right? L2 is here. None of them are null. So what I'm going to do is I'm going to compare them. You see L2 is smaller. So what I'm going to do is I make L2 as a currents next. So I assign the next here. Move L2 here and make it current. Okay, so this is exactly what we're doing here. We are moving L2 to L2's next and also moving the current. Okay, next, what I'm going to do is L1, L2, none of them are null, right? None of them are null. So none of them are null. So I compare again between L1 and L2, list one and list two. Now I see L1 is smaller, right? So what I'm going to do is, I am going to like do few things. I am going to move L1 here. I am going to assign this to currents next, right? Okay. And then I'm going to make this new node as my current. Okay. Okay, let's also move this, and this is also okay. Next, I compare between L1 and L2. You see that L2 is smaller. So what I'm going to do is I'm going to assign currents next to L2, and then I am moving L2 here. Okay, and I am moving current here. I compare next between L1 and L2. Both of them are the same. So what I'm going to do is I'm picking from L1, assigning the currents next to L1, and then moving L1 to null and moving current here. Okay, moving current here. Next, you see comparing between L1 and L2. Okay, I can't compare anymore because L1 is already it's null. So what I do is I take rest of L2 and just make it assign my next here, and I'm done. Okay, I just take whole of L2, whatever is left. Okay, so next what I do, you see dummy is still here, staying here, right? So I just return dummy dot next. Where is dummy dot next? This one, right? This is dummy dot next. Okay, so I get this one returned. That means my list now is looks like this. This starting from here, it comes here. So this is my output list. Now, okay, so this is my output list. I am just returning this. Okay, so this is my output list. What is the time complexity? After every comparison, I am doing say like one assignment. So if this list has a length of n and has a length of m, then it's order of m, that n plus m. That's the time complexity, right? You can say, okay, you didn't process all these, right? Yes, but in the worst case, both the lists are of the same size or something, or right? In the worst case, what I have to do is I have to keep on comparing. Like one of them is not going to be exhausted. So I just keep on doing it until just one node is left. So the time complexity is order of n plus m. Space complexity, you see, we didn't use anything extra. We just use one dummy node. That's a constant, like order of one. And every other node was just use the input, right? We didn't create any new nodes for these, right? So we just reuse them. We just reassign the links, cut this link and put it here, cut this link and put it here, right? So use the same nodes. So no space was used. So that's it. I hope you understood the problem. A few things to learn is how to create a list node. It's just like in Java, you can just create a class and have a value and also a next pointer to another list node. That's it. And this is the code. I suggest everyone to recode it yourself and submit it and see what your performance is. It should be pretty good because it's yeah, even it shows faster, and we saw the time complexity. It's a pretty good algorithm. So thanks for watching, and we'll come back with another problem later.